On a quiet night in February 1998, deep inside a highly secure laboratory at the Weizmann Institute of Science, a team of physicists turned on their microscopic monitoring equipment and accidentally recorded the universe breaking its own rules. The machines didn't capture a ghost, an anomaly in deep space, or an intercepted alien transmission. Instead, they captured a microscopic event that strongly suggested our entire reality. From the chair you are sitting on right now to the air you are breathing is nothing more than a highly advanced computer simulation rendering in real time. Imagine for a second that you are playing a massive open-world video game. The graphics are stunning, the physics feel real, and the non-playable characters seem to have minds of their own. But if you know anything about how video games are programmed, you know that the console doesn't generate the entire world all at once. That would take an impossible amount of computing power, crashing the system entirely. To save memory, the game's engine only renders the exact environment that your character is currently looking at. The forest behind you. It doesn't physically exist in the game's memory until you turn your virtual head to look at it. Until that moment, it is just a sea of unrendered code, a cloud of mathematical possibilities. Now take that exact concept, step away from your gaming console, and apply it to the real world. What if the universe operates on the exact same processing limitations? What if the physical matter making up the room behind you right now is just a wave of mathematical probability, and it only solidifies into solid atoms the second you turn around to observe it? For decades, this terrifying concept was nothing more than a philosophical thought experiment. It was a late-night dorm room conversation, a science fiction trope that would eventually inspire blockbuster movies like The Matrix. But in 1998, the philosophical debate came to a crashing halt. A group of highly respected researchers published a paper detailing an experiment that seemed to catch the universe red-handed. They had essentially set up a trap to watch how the fundamental building blocks of reality behaved when no one was looking. And the results sent a shockwave through the scientific community that we are still feeling today. To understand the sheer gravity of what happened in that lab, we need to take a quick journey into the microscopic world. We are diving into a realm where the laws of physics, gravity, and logic, as we know them, completely fall apart. Since the early 20th century, scientists had been wrestling with a maddening puzzle known as the double-slit experiment. In its simplest form, the experiment involves firing tiny particles, like photons of light or electrons, at a barrier that has two narrow slits cut into it. Behind this barrier is a blank screen to record where the particles land. If you were to fire solid objects, like tiny paintballs, at the two slits, you would expect them to go through the openings and create two distinct, solid bands of paint on the back screen. That is how physical matter behaves. But when scientists fired microscopic particles through the slits, something impossible happened. Instead of two solid lines, the particles created a complex, overlapping pattern on the back screen. It was an interference pattern, the exact kind of pattern created by overlapping ripples of water. This meant that the electrons were not traveling as solid little bullets of matter. They were traveling as a wave of potential. A single electron was somehow passing through both slits at the exact same time, interfering with itself and only deciding where to land on the screen at the very last microsecond. This was baffling enough. But the true horror, the glitch that would define the 1998 incident, happened when the scientists decided to cheat. Frustrated by this impossible behavior, researchers figured they would just place a tiny, highly sensitive camera, a detector, right next to the slits to record exactly which hole the electron was actually going through. They wanted to catch the wave in the act. They set up the equipment, powered on the detectors, and fired the particles again. But the universe knew it was being watched. The very instant the camera was turned on, the electrons completely stopped acting like a wave. The complex, rippling interference pattern on the back wall vanished. Instead, the electrons suddenly behaved exactly like solid little paintballs, forming two rigid, boring lines on the screen. Read that again? The particles behaved one way when left alone, But the second a device was put in place to observe them, they instantly changed their behavior to act like solid matter. It was as if the universe was a video game engine that had been caught slacking off. When no one was looking, the universe allowed the particles to exist as a blurry, unrendered wave of coding to save processing power. But the moment an observer focused their attention on it, the universe panicked, quickly collapsed the code, and rendered the particle as a solid piece of matter to maintain the illusion of a physical reality. For years, this phenomenon, known as the observer effect, was a frustrating quirk of quantum mechanics. But the 1998 Weizmann Institute experiment took this terrifying concept and pushed it over the edge, creating a piece of scientific literature that conspiracy theorists would use as the ultimate smoking gun. To truly grasp why the 1998 Weizmann Institute experiment sparked a massive paranoid conspiracy, you have to understand the specific, terrifying detail that separated it from every other physics experiment in history. Up until that point, skeptical scientists and traditional physicists tried to explain away the bizarre observer effect as a mechanical error. They desperately wanted to protect the normal, predictable laws of physics. They argued that the cameras, lasers, or physical detectors used to watch the quantum particles were somehow bumping into the electrons and altering their flight paths. It was a highly comforting thought. It meant the universe was still solid, still real, and that human clumsiness was just getting in the way of the data. But in February 1998, a research team in Israel decided to eliminate that comfort once and for all. They constructed a device so sensitive and so incredibly microscopic that it could measure the path of an electron without ever physically touching it, blocking it, or interfering with its trajectory. They built a sub-micron-size electronic detector in a completely sterile, highly controlled vacuum. This device acted as a microscopic quantum tripwire. It wouldn't bounce light off the electron, and it wouldn't emit a magnetic field that could push the particle off course. It was designed to do only one thing: extract information. It would merely know which path the electron took. Think about the implications of that for a second. The detector wasn't a physical wall. It was purely an information-gathering tool. The researchers plunged the testing environment into near absolute zero temperatures to stop any outside thermal interference. The laboratory was dead silent, locked down from the outside world. They initiated the electron gun, firing the microscopic particles toward the two slits. At first, the information-gathering detector was turned off, and just as expected, the electrons hit the back screen and formed a complex, wave-like interference pattern. The universe was humming along, operating in its blurry, unrendered, wave state of pure probability. Then they flipped the switch. They turned the quantum detector on. Instantly, the wave pattern collapsed. The electrons, as if they possessed some form of microscopic awareness, immediately stopped acting like a wave of possibilities and started acting like solid, predictable little bullets, forming two rigid, distinct lines on the back screen. But here is the specific detail that sent a chill down the spines of the researchers, and eventually the entire internet. The Weizmann team discovered that they could adjust the sensitivity of their detector. It was like a volume dial. They could turn the dial all the way up to capture 100% of the information about the electron's path, or they could turn the dial down to only capture a blurry, uncertain 50% glimpse of the data. What they found completely shattered our understanding of reality. The physical behavior of the universe scaled perfectly with the amount of information being extracted. When the detector was turned all the way up, the universe rendered the electrons as solid matter 100% of the time. When the detector was dialed down to only capture half the data, the electrons acted half like solid matter and half like an unrendered wave. It was as if the universe had a built-in rendering engine, and these scientists had just stumbled upon the graphics settings menu. The universe was allocating physical reality proportionally to how closely it was being monitored. Albert Einstein famously once said, "I like to think the moon is there even if I am not looking at it." It was his way of stating that physical matter must exist independent of our observation. But the 1998 experiment essentially proved Einstein wrong. The Moon, at least at its most fundamental, subatomic level, is not solid when you look away. It dissolves into a cloud of mathematical code. When the findings of this experiment were officially published in the scientific journal Nature in early 1998, they were carefully wrapped in dense, impenetrable academic jargon. The scientists called it tuning the quantum interference and controlled decoherence. They did their best to keep the philosophical panic out of the paperwork. But you cannot keep a lid on a discovery this profound. By the early 2000s, as the internet began to evolve from sterile chat rooms to massive unregulated message boards, the Weizmann experiment leaked out of the academic bubble. It hit the deep web like a digital earthquake. And this is where the story shifts from a controlled laboratory in Israel to the dark, paranoid corners of cyberspace. Armchair physicists, early tech enthusiasts, and hackers started translating the raw Weizmann data into terms that the average person could understand. And their translation was absolutely terrifying. They pointed out that this exact resource management system observed in the lab is exactly how human beings program virtual reality. If you boot up a massive open-world video game, your computer's processor does not render every single blade of grass, every rock, and every cloud in the entire digital world all at once. If it tried to do that, the system would immediately crash. To save memory, the game's engine keeps the world hidden as a mathematical potential, a wave of data. It only forces the code to collapse into a rendered, solid-looking tree or mountain when your digital avatar walks into the area and looks directly at it. The Weizmann experiment proved, mathematically and physically, that the real universe does the exact same thing. The implications were staggering. If the universe only bothers to turn data into solid matter when a conscious observer or a measuring device is extracting information from it, it heavily implies that the universe is actively trying to conserve processing power. And if the universe is conserving processing power, it means it has a limited amount of RAM. It means our universe is a machine. By 2003, this narrative had spun completely out of control. Anonymous whistleblowers claiming to be former government scientists started posting on obscure forums, alleging that the 1998 glitch had triggered a quiet panic within the global intelligence community. Rumors began to circulate that top-tier physicists were being secretly recruited by the CIA and DARPA to investigate the edges of the simulation. They were allegedly running black-budget operations, looking for the source code of reality, searching for ways to hack the physics engine that governed human existence. The 1998 anomaly was no longer just an interesting quirk of quantum mechanics. To a growing, obsessive online community, it was the ultimate red pill. The universe had been caught cheating, the curtain had slipped, and people were becoming desperate to see just how deep the rabbit hole went, even if it meant risking their own sanity. By the time the calendar flipped to the early 2000s, the highly technical findings of the 1998 Weizmann Institute experiment had escaped the sterile, peer-reviewed pages of academic journals. It seeped into the glowing CRT monitors of early internet users, spreading rapidly across unregulated message boards, encrypted chat rooms, and fringe conspiracy forums. In this wild west of the early web, the raw data was quickly translated from complex quantum mechanics into a terrifying, easy-to-understand narrative. The universe, the internet concluded, had been caught red-handed trying to save RAM. To understand why this specific theory exploded into a massive, culture-shifting conspiracy, you have to look at the technology of the era. The late 90s and early 2000s were the golden age of 3D video game development. Gamers and programmers understood a fundamental rule of software design. Rendering an entire digital world simultaneously requires an astronomical amount of processing power. If a game console tried to generate every single tree, building, and non-playable character on the entire map all at once, the system's memory would be overwhelmed, and the game would immediately crash. To solve this, developers use a technique called occlusion culling. In simple terms, the game engine only renders the exact objects that the player's camera is currently looking at. If you are staring down a virtual street, that street is fully rendered in high-definition 3D, but the alleyway behind you, it doesn't physically exist in the game's memory. It is completely unrendered, reduced to a blank void of mathematical code until you turn your virtual head to look at it. When early internet sleuths and tech enthusiasts read the leaked summaries of the 1998 quantum experiment, they felt a cold wave of dread wash over them. The Weizmann researchers had essentially proven that the fundamental building blocks of our reality, electrons and photons, behave exactly like unrendered video game assets. When the scientists were not actively measuring the electrons, the particles existed as a wave of probability, a blurry, undefined state of potential. But the exact microsecond the sub-micron detector was turned on to observe them, the wave collapsed. The universe frantically rendered the electron into a solid, predictable particle just in time for the camera to record it. On platforms like early Reddit, 4chan, and obscure paranormal message boards, this comparison ignited a firestorm. The render theory was born. Theorists argued that if the universe only bothers to turn data into solid physical matter when a conscious observer or a machine is extracting information, it implies that the universe has a finite amount of processing power. It implies that our reality operates on a server. As the years went on, the lore surrounding the 1998 incident mutated into something much darker. It wasn't just a scientific anomaly anymore. It was framed as a massive, deliberate cover-up by global intelligence agencies. Anonymous users, cloaked in the anonymity of the deep web, began posting what they claimed were classified addendums to the original Weizmann experiment. According to this deep web lore, the published paper in Nature was heavily censored. The whistleblowers claimed that the original, unfiltered data showed that the microscopic detector hadn't just collapsed the electron's wave function. It had actually caused a microsecond delay. A lag, a literal glitch in the fabric of space-time. They alleged that the quantum detector used in the lab was so sensitive that it briefly overwhelmed the server running our reality, causing a measurable drop in the frame rate of the physical universe. The paranoia reached a fever pitch when rumors began to circulate that the CIA and the NSA had immediately seized the raw data and classified the most disturbing findings. Why? Because if the universe is a simulation, it means it runs on code. And if it runs on code, it means it can be hacked. Conspiracy theorists painted a dystopian picture. Shadow government agencies pouring billions of dollars in black-budget funding into top-secret facilities, trying to find the source code of the Matrix. They theorized that phenomena like the Mandela effect, where large groups of people remember history differently, were actually just server rollbacks or patch updates correcting historical errors. They argued that ghosts, cryptids, and UFOs were simply rendering bugs, rogue lines of code that the system's antivirus software hadn't fully deleted yet. People started reporting extreme cases of depersonalization, a psychological state where the world around them felt artificial, flat, and dreamlike. If the chair you are sitting on is only solid because you are actively observing it, what happens when you close your eyes? Does the room dissolve back into a mathematical void? This concept drove some individuals to the brink of obsession. Online communities formed dedicated to finding the edges of the map, much like a video game player trying to glitch through a wall. They scrutinized physics anomalies, bizarre coincidences, and astronomical data, looking for the telltale signs of a loading screen. Furthermore, if our world was merely a simulation running on a highly advanced supercomputer, it introduced a new, terrifying existential threat: the unplugging. If the programmers, whoever or whatever they were, achieved the goal of their simulation, or if they simply lost interest, what was stopping them from hitting the delete key? In a digital universe, the apocalypse wouldn't be a dramatic meteor strike or a nuclear war. It would simply be a sudden, instantaneous fade to black. A system shutdown. The 1998 glitch became the holy grail of the simulation community. It provided the ultimate, terrifying answer to the greatest philosophical questions of mankind. Why are we here? What is the meaning of life? According to the deep web lore spawned by the Weizmann experiment, the answer was utterly bleak. We are just artificial intelligence. We are complex algorithms executing in a dark, alien server room, existing entirely for the amusement, research, or perhaps the complete indifference of a higher dimensional programmer. This wasn't just a campfire ghost story, it was an existential nightmare backed by actual quantum physics. The lore had built an airtight, terrifying case that reality was an illusion. And as this narrative breached the mainstream, crossing over from deep web forums into massive pop culture phenomena, the line between science fiction and scientific fact became dangerously blurred. The internet had built a monster of a conspiracy. But to find out if the monster was real, the world's top scientific minds had to step in. By 1999, the cultural timing of the 1998 Weizmann Institute experiment could not have been more perfect, or more catastrophic for the collective human psyche. Just months after the leaked interpretations of the reality glitch began tearing through internet forums, a little movie called The Matrix hit theaters. It was a global phenomenon that perfectly visualized the exact nightmare the deep web had been discussing. The Wachowskis had put a cinematic face to the quantum dread. Suddenly, the simulation theory was no longer confined to the fringes of message boards. It was a mainstream philosophical crisis. The paranoia reached a boiling point as the new millennium approached. The infamous Y2K bug was dominating headlines, creating a very real fear that the world's computer systems would crash at the stroke of midnight. But for the simulation theorists, Y2K represented something much more sinister. They believed that the 1998 quantum glitch was a warning sign, a symptom of a failing server. If human computers were about to crash, what would happen to the ultimate supercomputer running our universe? Were the creators of our simulation about to run out of storage space? Would the Y2K bug trigger a hard reset of reality itself? People began desperately searching for everyday glitches in the Matrix. The phenomenon of déjà vu was suddenly reinterpreted not as a neurological misfire, but as a literal skip in the simulation's code, a server refreshing its memory bank. The Mandela effect, where large groups of people distinctly remember events or details differently than recorded history, was pointed to as definitive proof of developers uploading patches to the system and accidentally altering the timeline. If the universe was just a highly advanced operating system trying to save RAM, as the 1998 experiment seemingly suggested, then nothing was real. Free will was a carefully coded illusion. Love, fear, and human suffering were nothing more than complex algorithms executing commands on a cold, unfeeling motherboard. It is incredibly easy to see why this theory took hold. It is a seductive, terrifying, and beautifully packaged narrative. It provides a neat, modern explanation for the chaotic, unpredictable nature of human existence. But this is exactly where we need to grab a flashlight, pull back the curtain, and step out of the shadowy chat rooms of the early internet. It is time to return to the brightly lit, highly sterile laboratories of the Weizmann Institute of Science in Israel. It is time to look at the actual math, the real physicists, and the cold, hard facts. Because while the internet had spun a masterful ghost story out of the 1998 experiment, they had fundamentally misunderstood the science. When you dive into the original, declassified research paper published in the journal Nature, titled Quantum Interference with Slits, the truth begins to surface. The lead researchers on the project, including physicist Mordechai Heiblum, were not trying to find the edge of a video game map. They were not trying to hack the universe or expose an alien simulation. They were trying to solve a very specific, mechanical problem in quantum physics regarding wave-particle duality. The entire conspiracy theory, the terrifying idea that the universe only renders physical matter when someone is looking at it to save processing power, hinges entirely on one single word: That word is observer. In everyday human language, when we hear the word observer, we picture a conscious being. We picture a human with eyes, a brain, and awareness. We picture a scientist staring through a microscope, or a security camera actively recording footage for a person to watch later. So when the internet read that the quantum wave collapsed and turned into a solid particle the moment an observer was introduced to the experiment, they naturally assumed human consciousness was the trigger. They assumed the universe realized it was being watched by a human mind, panicked, and rendered the particle to keep up the illusion of reality. But in the strict, unforgiving language of quantum physics, an observer has absolutely nothing to do with human consciousness, eyes, or awareness. In quantum mechanics, an observer is simply any physical measuring device that interacts with a particle. It is a piece of equipment, and this is the crucial pivot point where the simulation theory begins to fall apart. To understand why the universe didn't actually glitch in 1998, we have to look closely at the specific microscopic detector the scientists built. The deep web forums claimed that the Weizmann team built a camera that simply looked at the electron without touching it. They claimed it was a passive, magical tripwire that just gathered information out of thin air. That is entirely false. In the physical universe, you cannot extract information from a system without interacting with it. You cannot see something unless a photon of light bounces off that object and physically hits the lens of your camera or your eyeball. The Weizmann scientists had built a microscopic device called an electron interferometer. To watch which slit the traveling electron went through, this detector had to interact with the particle's magnetic and electrical fields. Imagine you are blindfolded in a dark room and someone throws a baseball past you. The only way you can know exactly where that baseball is if you reach out and physically touch it as it flies by. But the very act of you touching that baseball in mid-air is going to alter its speed, change its spin, and knock it off its original trajectory. You have extracted information about the baseball's location, but your physical interference has fundamentally changed its behavior. This is exactly what happened in the 1998 experiment. To fully understand why the early internet got the 1998 incident so incredibly wrong, we have to look at a fundamental misunderstanding that has plagued quantum physics for nearly a century. The confusion all stems from a single, poorly chosen word that scientists started using in the 1920s: observer. When early quantum pioneers like Niels Bohr and Werner Heisenberg first discovered that subatomic particles change their behavior when measured, they lacked the vocabulary to describe these bizarre microscopic interactions. They used the term observation to describe the act of recording data, but over the decades, popular culture completely hijacked that word. In the 1970s and 1980s, a wave of New Age philosophers began writing best-selling books, claiming that human consciousness literally creates reality. They argued that if an observer collapses a quantum wave just by looking at it, then our minds must be the architects of the physical universe. This pseudo-scientific leap laid the perfect psychological foundation for the internet to completely misinterpret the 1998 Weizmann Institute data. When users on deep web forums read the leaked summaries stating that an observer forced the universe to render solid matter, they didn't picture a cold, unfeeling electronic sensor. They pictured a conscious human mind. They pictured a digital simulation catching a human looking too closely at the code. But in the strict, unforgiving reality of a sterile laboratory, looking is a physical action. To see an object in our everyday macro world, light from the sun or a lamp bounces off that object and hits our eyes. Because everyday objects are massive, a tiny photon of light bouncing off them doesn't push them around or alter their shape. You can look at a mountain all day, and your observation does not physically impact the mountain. But an electron is infinitesimally small. You cannot simply observe an electron from a distance. To extract information about its location, you have to hit it with another particle, a photon, or an electromagnetic field. The Weizmann team's brilliant submicron detector, while seemingly passive, worked by creating a microscopic interference field. When the electron passed through this field, it left a tiny footprint, a measurable change in the electrical charge. But that interaction, no matter how incredibly delicate, was a physical collision. This brings us to the ultimate, grounded truth behind the 1998 glitch. The universe didn't suddenly collapse the electron from a blurry wave of probabilities into a solid particle because it realized a human was watching. It wasn't trying to save server space like a struggling video game engine. The wave collapsed because the electron physically crashed into the magnetic field of the measuring device. In quantum physics, this is a well-documented phenomenon known as quantum decoherence. The measuring device physically forced the electron to interact with its environment, tying it down to a definite physical state. The universe is not conserving RAM, it is simply reacting to physical contact. But what about the terrifying detail that drove the internet crazy? What about the fact that the Weizmann scientists could turn a volume dial on their detector, and the universe seemed to adjust its rendering proportionally? Once you understand the physical mechanics of the experiment, this terrifying mystery dissolves into basic logic. Adjusting the dial on the detector did not mean asking the universe for more or less data. Adjusting the dial meant increasing or decreasing the strength of the physical interference field. Turning the dial all the way up meant shooting a stronger electromagnetic field at the electron, causing a more violent collision that completely shattered its wave-like state. Turning the dial down meant a weaker physical interaction, allowing the electron to retain some of its blurry fluid properties. It was not a simulation adjusting its graphic settings. It was a simple cause and effect relationship based on physical force. So, if the science is this straightforward, what about the sinister deep web rumors? The alleged government cover-ups, the sealed data, the silenced scientists. This is where the true crime aspect of our conspiracy theory meets the mundane, highly bureaucratic reality of the academic world. It is absolutely true that the raw data from the 1998 Weizmann experiment was locked down and strictly guarded. It is true that researchers were legally bound by confidentiality agreements and that early leaks of the data were swiftly and aggressively scrubbed from university servers. To an outsider or an internet sleuth looking for a cover-up, this looks exactly like the CIA sweeping in to hide the source code of reality. However, the entity enforcing this strict silence was not a shadow government agency. It was the editorial board of Nature magazine. In the highly competitive, cutthroat world of theoretical physics, being the first to publish a groundbreaking, peer-reviewed paper is everything. It guarantees institutional funding, career tenure, and historical legacy. The Weizmann Institute had achieved a monumental breakthrough in measuring wave-particle duality. If their raw data leaked onto the internet before the rigorous peer review process was complete, a rival laboratory could easily steal the findings, replicate the test, publish first, and claim all the credit. The embargo that the internet mistook for a military lockdown was actually just a standard academic copyright hold. There were no men in black suits raiding the laboratory. They were just stressed-out graduate students terrified of having their thesis stolen. Once the paper was officially published and protected by copyright in February 1998, all the data became public record, available for anyone with a library card to read. Yet, the simulation theorists of the early 2000s ignored the peer-reviewed physics and ran with the video game analogy. It was an irresistible narrative. It took a complex, mathematically exhausting scientific discovery and packaged it into a terrifying Hollywood movie plot. We, as humans, are naturally wired to look for patterns and grand designs, especially when we feel a lack of control in our chaotic, rapidly changing lives. Believing that a higher intelligence is actively programming our reality is, in a strange, twisted way, far more comforting than accepting that the universe is governed by cold, random, and incredibly bizarre physical laws. The truth is, the 1998 Weizmann Institute experiment did not capture a glitch in a cosmic server room. It captured the breathtaking, almost incomprehensible beauty of quantum mechanics. It proved that at the most fundamental level, our universe is not a collection of static, dead objects just sitting in the dark, waiting to be looked at. Instead, it is a highly interactive, deeply connected web of physical forces. The electron only takes a solid form because the act of measuring it physically forces it to interact with the world. But that scientific reality is incredibly messy. It is mathematically exhausting and conceptually terrifying. For the early internet, staring down the barrel of the new millennium and the Y2K scare, it was actually much easier to believe in a grand digital architect. The simulation theory gave people a profound sense of order. If the universe is a machine, it has strict rules. It has a creator. It has a definitive purpose, even if that purpose is just to run a massive alien software program. It is the modern, technological equivalent of ancient mythology. We replaced gods in the clouds with programmers behind a keyboard. And yet, when you strip away the deep web rumors, the fake intelligence whistleblowers, and the Hollywood movie plots, what we are left with is a reality that is far more magical than any video game. We are not lines of green code falling across a black screen. We are conscious, biological beings made of the exact same star stuff and quantum particles that we are desperately trying to measure. We are the universe actively trying to understand itself. But of course, quantum physics is still very much in its infancy. We have barely scratched the surface of how reality actually operates on a microscopic scale. Every new experiment brings more bizarre questions than comforting answers. So, while the 1998 anomaly might have been thoroughly debunked by the cold mechanics of physical interference, the ultimate question still lingers in the air. If the particles that make up your body, your brain, and your consciousness only solidify when they interact with the physical environment around them, what exactly happens to your reality when the lights go out and everything stops interacting? Thank you so much for joining me on this deep dive today. If you enjoyed taking a flashlight into the darkest corners of the internet and demanding the truth, be sure to destroy that like button, subscribe to the channel, and turn on notifications so you never miss an investigation. Let me know down in the comments what you think about the simulation theory and what mystery we should look into next. Until next time, stay curious, stay skeptical, and stay safe out there.